Alright guys, we're just doing one last sound check before we get started. Hopefully you can all hear us. We have our slides up. Hopefully you can see that as well. So about one more minute and we're going to get rolling. All right, good morning. We are excited to try out this new presentation format with you this morning. I'm Sam.
And I'm Sally. We will be here along with Heather and Alicia for the next 30 minutes navigating through this virtual learning experience with you. For this to go well, we need to ensure everyone's mics are muted. However, you can still add into the discussion if you'd like. Alicia and Heather will be on the chat section answering questions while Sam and I present.
If at any time throughout the presentation you would like to ask a question, you may enter it into the chat box. Alicia and Heather will do their best to answer your questions and troubleshoot as quickly as they can. Sally and I won't be pausing to answer any questions during the slide deck because we have lots to share and we only have 30 minutes. So hope you're ready because here we go.
Yeah, I'm really excited. I think it's going to go well. It's nice to see everybody saying hi, and we've seen Amy Ma's in charge over there in Confed and Queenie saying hi, so we're really excited to be all together like this today. So we're using familiar facts and math games today. That's what our focus is, so I'm looking forward to digging into this with all of you. For the first part of the presentation, we will be defining and noting the differences between familiar facts and using familiar facts. In the last half of the presentation, we will be looking at activities and games to support both familiar facts and using familiar facts.
Okay, so what are familiar facts? Let's dig in and find out. If students have an understanding of familiar facts, it means that they are able to come up with the answer when asked immediately without having to figure it out. What's important to know is that it is instantaneous automatic retrieval. So skip counting on fingers to solve 7 times 3 is not knowing 7 times 3 as a familiar fact. Familiar facts can also be known as known facts.
1, 2, 5, 10, and 25 are the most common familiar facts as they are easy to learn because all of the skip counting students are expected to achieve in the primary division. Skip counting is found in the curriculum starting in the 1st grade. It remains there through the 3rd grade. These are numbers primary students work with often, so it is easy for them to transition over to making these familiar facts. Some students, however, may be familiar with even more facts based on the time they've spent engaging in activities to develop other familiar facts.
Okay, so familiar facts does not mean memorization. We just want to clarify that a little bit. When explaining the difference between memorization and fact fluency to students, it's important to remember that a memory has its limitation. So memory is all or nothing. If you have something memorized, you simply know the math fact. Memorizing without understanding what's happening to the number doesn't support students' understanding of number sense and numeration. Familiar facts fluency is when students are able to make connections between facts. For example, if a student can't solve 6 times 7, they can use the familiar facts of 7 times 5 and 7 times 1 to solve it efficiently and quickly. These familiar facts will help them understand and make connections with other operations as well, such as multiplication to solve division problems or using addition to solve multiplication problems.
So let's take a second to do some math. Please solve this question mentally.
Sorry, I'm just giggling here because our coworkers are taking selfies during this presentation.
Okay.
Now, please go ahead and solve the second question. We will come back to these numbers in a little bit.
Now we're going to focus in on using familiar facts. Using familiar facts is located near the end of the continuum. It is close, oops.
Sorry, hold on. Back up. Put tools out here.
Okay, so yes, it's located here towards the end of the continuum. It's close to proficiency in the phase of working with the numbers. Notice all the strategies that come before working with familiar facts. If you jump too far, too fast, it's a challenge, as students wouldn't have developed any familiar facts. This strategy is for kids who have already had experience with the previous stages, as those strategies are what they would have used to develop familiar facts.
Using familiar facts is simply using the known fact to help you solve an unknown situation. You likely use a familiar fact to solve the second question, 2 times 19. On the next slide, we've included a few examples of how using familiar facts could have been used to solve 2 times 19. Here are examples of multiplication using familiar facts.
So these situations on the top are both solved in the same way. They are recorded a bit differently, but both are using 2 times 20. Oops. That's okay. They're both using 2 times 20. So let's say we have 2 classes of 20 students. We know that if we take away 1 student from each class, then we have 2 classes of 19 students. So we must remove 1 student from 2 classes. To use the familiar fact, we end up taking away 2 students from our familiar fact answer of 40, which gives us the answer to 2 times 19, which is 38.
And for the bottom one, I used smaller facts, smaller chunks. I split up 19 into 10 times 2 equals 20, 5 times 2 equals 10, and 4 times 2 equals 8, and then added them all together.
Yeah, so the first examples were overshooting. We're using the higher number, and then in yours you're building up to get to your answer using familiar facts.
Yep. Okay, so here's the fun part. We've shared some games with you that will help to develop familiar facts. So to clarify, these will be games to develop familiar facts. Later in the slideshow, we will share other games that actually use those familiar facts that have previously been developed.
We've created a Google Drive folder that we will share with you at the end of the slide deck. In the folder, you will find a few examples of games that you can use to support developing familiar facts. The drive will look like this. It will also have the games for using familiar facts from today. The QR code and bit.ly will be on the last slide, so you'll be able to access it right away.
Okay, so this is some sample of the games you will have. Each game is in a folder with the rules attached, as well as any game boards necessary to play.
Yep.
Double Double, Facts War, Target 75, Target 300, Last One to School. Quite a few to choose from.
And there's some videos in there too.
Okay, our next section will focus on using number talks in your classroom to support using familiar facts. Number talks are a great, quick way to support so many different number sense strategies.
One way to support the development of using familiar facts is to regularly conduct number talks in your class. Here are 2 books that can help you with this. These books are great because the number sequences that will develop using familiar facts are all thought out for you in these books. You can somewhat see in this image that there are 9 sets of sequences on each page. In the sequence shown here, students are asked to solve 16 times 25 in the end. But before that, they are using familiar facts so that it's supporting students to learn to use those familiar facts to solve the bigger question in the end. Here are some examples from number talks from classes in our board. In this first example, Lauren is using her connection between multiplication and division to solve 45 divided by 3. She knows that 3 times 10 equals 30, so she knows 30 is divided by 3 is 10. And then with her remaining 15, she knows 5 times 3 equals 15, so she's able to solve 15 divided by 3. Another student is using his familiar facts of 5 times to solve. He visualized this problem in an open array model. He knew 3 times 5 equals 15, so he used this familiar fact until he was able to reach 45. This allowed him to see that each row consisted of 15, as noted on the top with the numbers. So then that gives him his answer, the quotient. In this final example, the child is using 4 times 12. She was able to use her 10 times facts as her familiar facts and her doubles to find the solution. She too used an open array to explain her thinking. Our friend Teen suggested this format to encourage students to use familiar facts. It's a file called Just the Facts, and it's in the Drive folder we created for you. Students should be encouraged to start with the most familiar fact and use it to solve the other ones. Students will likely solve 8 times 2, then 8 times 10, and then 8 times 5 first. They could then be asked to share how they used these familiar facts to solve another question on the board. For example, I used 8 times 2 to solve 8 times 4 because 8 times 2 is 16, so I just doubled 16 to find the product of 32.
I would use 8 times 5 and 8 times 4 to find the answer of 8 times 9.
And another student might say if 8 times 10 is 80, then 8 times 9 is 72 because it's one less group of 8. I feel like this format is a great way to support students to strengthen their connections between the numbers to use their familiar facts.
Awesome. Now we're going to spend some time sharing some new games with you that supports actually using those familiar facts previously developed. Again, all of the stuff for these games will be in that Google Drive folder as well.
Yeah.
So the first game we're going to explore is Familiar Facts War. Students will need to have concretely explored and some understanding of some of the following concepts before playing this game. So partial product would be the ability to break apart a number into friendlier numbers to multiply. The relationship between multiplication, so an understanding that 6 times 7 is the same as 7 times 6. An understanding that numbers are nested in other numbers means knowing that 9 is made up of 8 and 1, or 5 and 4, and some experience building arrays to multiply. So also need to have some automaticity with familiar facts like 2s, 5s, 10s, 25s.
In this example, a student is concretely exploring using familiar facts to solve 7 times 5. The student is splitting the 7 into a 5 and a 2 to create 2 simpler facts of 5 times 2 and then 5 times 5.
The purpose of this game is for students to use familiar facts to solve unfamiliar ones. The materials needed will be the spinner, which is included in the Google Drive, and the game sheet, also included. The aim of the game is to be the player with the greatest number of rounds won after 7 wars. Okay, so step 1. Player 1 spins the spinner 2 times and records the numbers into the boxes on the worksheet, as you can see here. Players will need to decide which number they would like to put in the box to split. For example, if a student spins a 9 and an 8, they chose to put the 9 into the box to split using familiar facts. Step 2. Player 1 then uses their familiar facts to solve. For example, they split 9 into a 5, a 2, and a 2, then they solve. After playing this game with students this week, we ended up having a conversation around ensuring they're using their familiar facts. Many students went to split their 9 into a 3, a 3, and a 3 because they thought, those are small numbers to work with, but then proceeded to skip count on their fingers. We had to stop and really dig into why that wasn't a familiar fact for them and what other options would have worked better. This is where we connect back to the idea that many students have 2s, 5s, and 10s as their familiar facts, which is why this student here chose to switch theirs to a 5, a 2, and a 2.
I think that's a good point because when we're playing games, we get to have a chance to sit and listen to our students, and I feel like we learn so much from our students when we have the chance to sit and listen while they're playing. Then we can pick out where they need to go next. It makes it just so easy to Yeah.
Yeah.
So we like have a chance to sit and listen to some, go move around to see some other students, and then we get an idea who needs a little like support with that or who's ready to start trying some other strategies.
And the ability to give this quick piece of feedback here for this student helped him to provide it instantaneously, and then for the rest of the game, he then thought about using those familiar facts through the game.
Yeah.
Awesome. Okay, step 3, player 1 then solves the equation. Player 2 then spins and solves, splitting and using the familiar facts. So player 2, if you can see here, decided to split 7 into familiar facts. And notice that they added a third little line for splitting. That's totally okay. This student recognized that 3 would not be familiar and chose to use a 2 and a 1 instead. And that's awesome thinking on their part. Okay, so step 4, players then compare their score, and the person with the greatest product wins that round. Students can keep track with a tally chart, and play continues for 6 more rounds for a total of 7 rounds.
I really like how you just have them doing tallies down there because it's a simple way to keep track, but then you can also bump it up by having them keep track of their total points.
Yeah.
Like, so if they take all their products and tally those up or add those up,
yeah,
that will make it a little bit more of a challenge for some students.
Absolutely. Okay, so here are a few ways to bump this game up or bump it down based on student need. Just provided a few. So have manipulatives available for students to use to build the arrays to split. If you want the game to move quicker, try only playing for 3 to 5 rounds or putting a time limit on it. You could use a spinner with smaller numbers such as 0 to 6 to start until the students felt more comfortable. You could use a spinner with larger numbers such as 0 to 12 or create your own. We actually did that this week. We started in a grade 6-7 classroom. We recognized that 0, 1, and 2 the kids were very comfortable with, so we ended up adding a 1 in front of each to make it a 10, 11, and 12. So what a quick adjustment, really changed the game. And you could provide students with the other game sheet, which is also included, and they could create 2-digit by 1-digit equations. You could also try 2-digit by 2-digit.
What I've noticed, like when we've been playing games in the classrooms, is that we'll play the game and then we'll notice, like, oh, this could easily be changed to support this student, or we can bump it up, we can change it, and then find so many different ways to play the game that are going to suit our students' needs. And then I love hearing, like, after I've been out of school and then they've been playing a game and then how students change the game or how the teachers have changed the game, and then that helps everybody because then I can pass that information on to other teachers that I'm working with.
Yeah.
That's why we're hoping that teachers in the end are going to share on Twitter, or I'm not sure where else they would share it. Share with their coaches, share with other teachers, share it on Twitter, so then we can see the modifications of the games. Yeah. So then it helps everybody.
Yeah, and then we can pass it along as well.
Yeah. Okay, the game I'm going to explain is Kinect for Division. In this game, students will use familiar facts to solve division questions. Prior to playing this game, students will need to have concretely explored and have some understanding of partial products, which we already discussed, and the connection between multiplying and dividing, and work with fair sharing and arrays to divide. Plus, they need to have some familiar facts they can draw upon. In these images, students are concretely examining the connection between multiplication and division using arrays. They will realize that one operation undoes the other. Students will also need to understand what dividing is, so breaking apart a number into equal groups. Plus, they would benefit from building arrays to divide, so they can understand that we can multiply up to divide. In the next slides, I'm going to show you how students would move from concretely exploring this idea to visually representing it to working with just the numbers, which is the third phase on the Lawson continuum. It's a bit lengthy, so please just hang in there with me and I will then explain the game. So in these examples, students are moving from concrete to a pictorial representation of dividing. Let's say the question is 75 candies to be shared between 5 students. The students will represent the 5 students with 5 rows. Sorry, I'm getting that confused. So the 5 on the side of our array here that we're building with tiles will represent the 5 students, which makes 5 rows. They start with sharing out tiles individually until all 75 candies are shared out. Students will begin to realize this is painful and begin to share out with tens. With some prompting, like how many groups of 10 did you share out, students will be able to begin representing this thinking in an open array combined with multiplication sentences without having to draw out the lines, because they know the number on the top represents how many candies each student will get or how many candies are in each row. So the 10 and the 15 represents that number that's been shared out, and they know that that represents those rows that they were previously sharing out. Here's an example of a class working to use an open array by multiplying up to reach the amount to be shared out. Here they have 72 candies to be shared out between 3 students. So you can see the 3 written on the side. Students share out chunks of candies until they're all gone. The row on the top tells how much candy has been shared out each round. So their answer is 24. Eventually, students will get more efficient with this model, as they will see they could have grouped their 10s together to make a 20 there. Once students have concretely, then pictorially, developed an understanding of using familiar facts to divide, they are ready to move to working with the numbers. You can see how these 2 images are essentially the same thing, but one has a visual that will support student understanding. When working with the numbers only, students are able to represent their thinking with just the numbers. They might think, I have 75 to be shared out equally. I know that if I have 5 students and I give them 10 candies each, that will use up 50 of my candies. Then if I give out 5 more, that will share out 25, and then I have nothing left. So in total, I gave out 15 candies each round, and that gives me my answer of 15. This is an example of students playing the game in a class at A or right.
Okay, students will need the game board, a multiples deck, a pencil to solve with, and a highlighter or pencil crayon for each player. Again, all of these materials will be provided in the Google Drive at the end. In the shared drive, you will find the multiples deck. They need to be printed on cardstock and cut. The game board is also in here with instructions and modifications. Just like a teacher tip, we played it this week in a classroom, and we printed off each multiple deck on a different color. Another class has done it where they printed off the even numbers on one color, the odd numbers on another, and then on the back of each deck they just wrote the multiple numbers so that you can keep track of what belongs with what.
Just depends how many different colors of cardstock are stocked up in the building.
Yeah.
Also, that you can't see on here is another game board, and it's in French. And actually, we should give a good shout out to Mariah Millette, who's been working really hard to support our French teachers.
Absolutely.
Yeah. So in our folder that you'll find some French games, the games translate into French, which is really nice for our French students. Okay, so to win the game, the student needs to be the first one to connect 4. They will need to use familiar facts to solve each division question. To begin, choose a multiples deck based on your goals for the students playing. If the multiples of 3 deck is drawn, then students will record the number 3 at the top of their page, indicating they are dividing by 3. Players place the deck face down between them. The first player draws a card, and their card is their dividend. They then record their number or sentence in one of the boxes. They pick one. So if the 36 was drawn, then they would write 36 divided by 3. Then students use familiar facts to solve, as seen in the examples. So this student and this student used 2 familiar facts to solve. This one here overshot the problem and took off a group. And then these 2 needed only 1 familiar fact to solve. Once students have correctly solved their question, they color in their square. And then the play just continues until someone connects 4. Here are some tips for teaching this game. Begin by using a smaller deck of multiples. Instead of using all multiple cards, like using a deck up to 99, for example, use multiple cards that only go up to 12 times the multiple. So if using a multiples deck of 3, then only use the numbers up to 36. And you can even make that smaller depending on your class and the age of your class. Teach the game on the smartboard first, so all students can see what is happening. Once students understand the process, partner students to play in teams against another set of partners. This will allow the students to support each other. When you're confident students understand the game and how to use the strategy of using familiar facts, allow them to play one player against another player.
And Heather had a great suggestion. She mentioned maybe try playing it with another teacher first to problem shoot any issues that may arise, and that will help you feel really comfortable introducing the game to your class.
We can make this game more challenging or less. Like Sam already discussed, use manipulatives for those still at the direct modeling and counting stage, or whiteboards for those who are becoming more efficient in tracking with a visual representation. We can make the game 3 in a row instead of Kinect 4 to make it shorter. Plus, we aim to keep our game times between 15 and 20 minutes. Not 50, 15. So 15 and 20 so that the students remain engaged. So if the game is not over, then have one student save the board. It will keep them interested. When students are confident with smaller decks, then bump them up to a fuller deck. Another change you could implement is switching the multiples decks. To make it more challenging, you could use a die to determine the divisor. This will give students a different number to divide by each time. This will leave students with some remainders. Finally, you could change the game by requiring students to only record with a division sentence, as seen in this example. Another one that I'm thinking of is instead of using the multiples decks too, they could just use cards.
Yeah.
Right? So if you're getting to a point where you want your students dividing by 3 digits, or having to divide with 3. No, we want to have the dividend as 3 digits and then divide by 1. So you could just draw 3 cards using the numbers 1 to 9.
Yep. And have your remainders.
Yeah. I can't wait to see what everybody else comes up with because I'm sure there'll be lots of awesome changes.
We loved the game this week.
Yeah, the kids liked it at AA, right?
Okay, we hope digging into using familiar facts this morning will help you to support your students in reaching their operation goals and lead them to becoming more proficient with multiplication and division. Remember to visit the blog for more ideas on supporting students in their progression through this continuum.
Here is the link and QR code for the resources from today. Don't forget to share your experiences with playing these games with everyone. We'd love to hear any changes you make to the games or games you have used to support the strategies. Also in that file, you will find some folders from the other sessions today too. So if there's some resources, you might find some other things that might help you if you're talking with your peers about what they did in their sessions.
Yeah, connect with your colleagues and see what they learned about today. And again, just want to make a quick mention too, we'd love to see some photos of you guys learning through Skype today, so feel free to share some of those photos with us if you haven't already.
We also want to say thank you so much to everybody who's engaged in helping us learn as coaches about the continuum, and then like I feel like we've just had such great partnerships with our teachers this year, like getting to be able to sort through this stuff. Like the continuum was new to all of us, and we all got to learn a lot together. Really enjoyed it.
Yep.
So thank you everybody who's put in the time and helped
welcomed us in your buildings.
Welcomed us in the buildings, and then helped the colleagues who don't have a coach in the room to understand the continuum and what we've been doing in the classes and all the sharing. It's been awesome.
So we're done with the presentation, but if you have any questions, please feel free to stay on. We're just going to hand over the mic or the chat room to Heather and Alicia, give them a chance to answer any questions that they might have been given. Enjoy your PD day and your weekend.
Yeah. Okay, we see that there's an issue with the little icon on the side blocking the QR code, so we're trying to work on that. But in the meanwhile, if you have questions, please feel free to type them. Alicia and Heather are going to be typing answers to the questions that you have.